All right, so we're trying to solve a problem which appeared in JEE Mains in 2015. In this question, we have been asked to find out the value of A10 minus 2A8 upon 2A9, wherein AN is given by this alpha raised to the power n and minus beta raised to the power n. And alpha and beta are actually the roots of this equation, quadratic equation, x square minus 6x minus 2. So this problem can be done in two ways. One is what we call it using a Newton's theorem, a Newton's formula for quadratic equation. And another is that using the simple method, that's whatever we know. So first is what we will do is we will apply Newton's theorem or Newton's formula for quadratic equation, and then we will use the alternative approach. So what is Newton's formula? And like you might have seen it in many places, but I'll still write it down for you. So if you've got ax squared plus bx plus c equals to 0 as your quadratic equation, and alpha and beta be your roots, then and then again whatever extra we are saying here, that your an sn, sometimes we call it as an, sometimes sn. So let's call it sn for the timing. Sn is given by, let's say, alpha raised to the power n plus or minus beta raised to the power n. So it will be valid for both the cases. Actually, in general, it will be valid for even Sn equals to alpha multiplied to any constant p, alpha raised to the power n plus minus q times beta raised to the power n, right? But in all these cases, like what will happen, that you can just simply put this uh, what you call Sn over here in this case, that it will be a into Sn plus 1 plus b into Sn plus c into Sn minus 1. That will be actually equal to 0. So that is what is your Newton's theorem or Newton's formula for quadratic equation. And this will be valid for, as you can see, you have to just go from higher to lower, as in n plus 1 to Sn minus 1. In this case, what you have been given is A10, A9 or A8. So simply put, in this case, this will be A into whatever be the coefficient of x square into A10 plus B into whatever be the coefficient for your x will be b, and Sn will be a9 over here, and then c into a8, and that will be actually equal to 0. So actually verifying this is pretty simple. Maybe we can try to verify this towards the end of this video. Right now, let's try to look at this. So in our case, the quadratic is given as x square minus 6x minus 2, right? So x square minus 6x minus 2 equals to 0. So what we have been given here is that a is 1, b is minus 6, and c is minus 2. So we can just substitute this value over here. So this will become a, which is 1 into a10, plus b, which is minus 6 times a9. C is going to be minus 2 times a8, and that will be actually equal to 0. Then what are we supposed to find out? A10 minus 2a8. All right, so we'll just keep a10 minus 2a8 this side, and then we'll send 6a9 on this side. But we want to find out 2a9 should be divided here. So we should bring in 2 times a9 here, 2a8 divided by 2 times a9, and that should be actually equal to 3. So this is what will be your answer. So 3 will be your answer using Newton's formula over here. All right. Now this is your approach 1. What will be your approach 2? If you don't know this, then how do you do this, right? And let's look at approach 2. So number 2 would be, we will use the same thing over here, which is given x square minus 6x minus 2 equals to 0. And what is given to us is basically A10, right? So A10 is nothing but alpha raised to the power 10 minus beta raised to the power 10, right? And then what is my A9? A9 is going to be simply alpha raised to the power 9 minus beta raised to the power 9. And then A8 would be alpha raised to the power 8 minus beta raised to the power 8. What we need to evaluate is A10 minus 2A8. So we'll just write down alpha raised to the power 10 minus beta raised to the power 10 minus 2 times a raised to the power 8, which is alpha raised to the power 8 minus beta raised to the power 8, right? Divided by 2 times alpha raised to the power 9 minus beta raised to the power 9, right? Now, let's look at closely here and then try to take alpha raised to the power 8 common. So then if I take alpha raised to the power 8 common from here, then I'll be left with alpha square minus 2 here. And if I take minus beta raised to the power 8 common, then I'll be left with beta square minus 2 over here. And then this thing will be 2 times alpha raised to the power 9 minus beta raised to the power 9. Now we will look at alpha square minus 2. What will this be? If alpha and beta be the root, then this should get satisfied with alpha and beta as well, right? So alpha square minus 6x minus 6 alpha minus 2 would be actually equal to 0. Or 6 alpha should be actually equal to alpha square minus 2. Similarly, I can say that 6 beta is going to be equal to beta square minus 2, right? So I can just put these values over here. This will become alpha raised to the power 8 into 6 alpha minus beta raised to the power 8 into 6 beta, right? Upon 2 times. And this is going to be alpha raised to the power 9 minus beta raised to the power 9, right? So then here it will become alpha raised to the power 9 and minus beta raised to the power 9. 6 times this will become alpha raised to the power 9 minus beta raised to the power 9 upon 2 times alpha raised to the power 9 minus beta raised to the power 9, right? And this will be cancelled. This will be cancelled in 3 times. And again, you got your answer as 3, right? All right. Now, the question might be that why does this work, right? If you want to see why does this work, we can again just do in 2 minutes. Like, what did we say? As in, like in general, that A times Sn plus 1 plus B times Sn plus C times Sn minus 1 should be equal to 0. And if I just substitute the value and then let's substitute the very generic one like P into alpha raised to the power n plus 1 plus and minus beta P, and then after that we had Q into beta raised to the power n plus 1 and then plus B times P into alpha raised to the power n plus or minus Q into beta raised to the power n and then plus C times alpha raised to the power n minus 1 plus minus beta raised to the power n minus 1, right? Now that is something we are supposed to find, right? In this case, again, whatever we have done here, we will do the same. Like we will take alpha raised to the power n minus 1 common, P into alpha raised to the power n minus 1 common. Then what I'm left with here is A alpha square. And then here I'm left with plus B alpha. And then here I'm left with plus C itself. While I take plus or minus Q into beta raised to the power n minus 1 common from here, I'll be left with beta square, actually A beta square plus B beta plus C. Now what is this? This is going to be 0 because alpha and beta be the root of ax square plus bx plus c, right? So ax square plus bx plus c is 0. Then this implies that a alpha square plus b alpha plus c is 0. And similarly, a beta square plus b beta plus c equals to 0, right? So of course, this will become p into alpha raised to the power n minus 1 into 0 plus minus q into beta raised to the power n minus 1 into 0, and that eventually will become 0, right? So this is basically the use of Newton's theorem or Newton formula for quadratic. And if you don't know this, this is what essentially we are trying to do over here as well. We're actually taking this common and then getting into this form itself. So you can choose either of these forms, whatever suits you. But even if you don't know Newton's theorem or Newton's formula, you will still be able to do all these questions. All right. So that's all for today. If you have any questions, do ask me in the comment section below, and I'll be happy to answer your queries. Thank you so much for watching this video. Have a good day.